Hello everyone, good morning. Today I will discuss T flip-flop and D flip-flop in this video. We will see T and D flip-flop and applications of the flip-flops. We have discussed SR and JK flip-flop in the last video. The function of the T flip-flop will be similar to JK flip-flop, only the difference is we have to connect both the inputs of J and K together. The problem in the SR flip-flop, that is indeterminate state, whenever both the logics S and R at 1. So this problem can be avoided in the T flip-flop. T means simple, toggle or trigger. It will toggle the output state. Fine. So now we will see this T flip-flop in detail. This circuit shows the T flip-flop. You can see here, this is nothing but the simple JK flip-flop, the circuit of the JK flip-flop. Only the change is that we have combined these two inputs, J and K together, and we are applying T here. T means toggle. The circuit will be same as we have seen in the JK flip-flop. Now we'll see what happened when we will give this T is equal to 0 and 1. So when T input is low, then the next state of the T flip-flop is the same as the present state. We have seen the function of the JK flip-flop. When J and K both are 0, there is no change in the output. And if J and K both are 1, it simply toggles the output bit. So similarly, we are combining these two inputs and will give T is equal to 0 and 1. So the function will be same as we have seen in the JK flip-flop. Suppose here T is 0, present state is 0, and the next state is also 0. And suppose present state is 1, then the next state is 1. Means there is no change in the state, output state. The second case, when we will give T input high, and during the positive transition of the clock signal, the next state of the T flip-flop is the complement of the present state. So when T is 1, suppose present state is 0, then the next state is 1. And suppose present state is 1, then the next state will be 0. You can see this in this table. This is the truth table of the T flip-flop. As we have already discussed, this arrow indicates positive edge trigger. We are using positive edge trigger flip-flop here. So whenever T is 0, so if Q is 0, then Qn plus 1 will be 0. This is what previous state, and Q plus 1 is current state. So there is no change in the output state, but when we'll give this T is equal to 1, then current state, suppose it is 0, the next state will be 1. And suppose current state is 1, then the next state will be 0. So simply it will toggle the output state. This is what T flip-flop. This is the characteristic equation of the T flip-flop. That is TQ bar plus D bar Q. Means simply whenever T is 1, it will give toggle output, and whenever T is 0, it gives same output. So accordingly, there is an equation. Fine. Now we'll discuss D flip-flop. D means delay. It gives delay in the circuit. Now, why we are using delay in the circuit? You can say, you may ask the question. See, in the television, suppose there are two inputs, audio and video. You know that audio will come fast, and after some time, video will come. So if there is no synchronization between this audio and video signal, then you can not see the picture properly. So there is a delay between audio and video signal. After some delay, we will give the audio signal to the video signal. Means there is a synchronization. To synchronize these signals, we are using delay circuits. So in some applications, we are using delay circuits. So this delay flip-flop, D flip-flop, simply it gives delay in the circuit. Means this input will pass to the output line after some delay. Okay, that device is known as transparent devices. Fine. You can see the circuit of the D flip-flop. This is nothing but the simple JK flip-flop as well as T flip-flop. But what is the difference between this T flip-flop and D flip-flop? Simply, we are using inverter here. So D, we are applying directly to this input, and complement input we are applying to this NAND gate. Friends, this is known as latch. Why I have written D latch? This is also known as flip-flop, but here I have written D latch because here in this circuit I am applying enable input, that is 1. Right. I mean, we will use level trigger clock pulse here. As we have discussed in the first lecture of the sequential circuit, that latch will work with level trigger of the clock pulse, and flip-flop will work with edge trigger of the clock pulse. So this is simple. Either this enable input is either 0 or 1. This is what? Level trigger of the clock pulse. This is, you can write here clock pulse also, CLK also. This is similar to this enable in the latch. Okay, so again I will tell you that in SR flip-flop there is an indeterminate state when S and R both equal to 1. So that state cannot use practically. To overcome this, we are using this different flip-flop JK, T and D. Okay, so in D flip-flop we can overcome the problem which we have faced in the SR flip-flop. Fine. Now, suppose enable input is 0. The circuit, means this circuit cannot change state regardless of the value of D. As we have seen in the JK flip-flop and T flip-flop also, that whenever we'll apply J and K and T inputs 0, then there is no change in the output state. Similarly, if we will give enable input is 0 and D is 0, then there is no change in the output state. But whenever this enable input is 1, and suppose if D is also 1, then the Q output goes to 1. Simply, it will pass this input here. Because you know, in the JK flip-flop and also in T flip-flop, we have discussed this state also, that whenever this input is 1, then the output will be 1. Right? Means the circuit is in set mode. Placing the circuit is in the state mode. If D is 0, output Q goes to 0. Placing the circuit in reset state, as we have discussed in the previous flip-flops, JK, T, right? So it will simply pass the input signal to output signal. So we can say this flip-flop is known as storage element. It will simply store the data. This is the symbol of D latch, and this is one truth table of D latch. Now you can see here, whenever enable input is 0, so if D may be 0 or 1, there is no change in the output. When enable line is 1 and suppose D is 0, Q will be 0. If D is 1, Q will be 1. So D ledge, it is nothing but simply hold the data. It will pass the input to the output line after some time. Okay, so we are using enable line, right? That is nothing but the simple ledge. Whenever active high and active low, the circuit will depend on this enable input. Now, friends, we will see the applications of the flip-flops. So all these types of flip-flops can be used in counters, in frequency dividers, in shift registers. In data transfer means simply it works as a storage element. All the flip-flops store the 1-bit memory data at a time. So these flip-flops are used in resistors. In previous lecture, I told you that the resistors are used in memory, and memory, you know, we are using in our daily life, in laptop, in computer, in mobile, we are using memory. So in memory, there are simple, we are using resistors. In resistors, we are using flip-flops. Okay, friends, thank you.